Hello, I'm Christiansen. In this video, I'm going to talk about identifying numbers as rational or irrational. Behind me, I have a picture of a pi with the Greek letter pi on it, which I thought was appropriate because pi is a famous irrational number. And we're going to see it in the problems. They look like this. They give you a list of numbers and they ask you to check off whether those numbers are rational or irrational. I'm going to do the first few problems pretty quick. And then in the next few, I'll give a little bit more detailed explanation. So for this first one, this first number is rational because it has a terminating decimal. Okay, so this one's rational. This next number is rational because it involves the square root of a perfect square. 4 is a perfect square, and so this is a rational number. In this next one, we have the square root of a number that is not a perfect square. So this is irrational. This number is rational because it has a repeating decimal. That's what this bar up here means. So because it has a repeating decimal, it's rational. This number down here is a multiple of pi. And because of that, it is irrational. Let's put in those answers real quick. Okay, we'll do this one quick as well. The first number is rational because it's the square root of a perfect square. 49 is 7 squared, so that's going to be rational. This next one is irrational because it's a multiple of pi. This number is rational because it involves a terminating decimal, or a decimal that comes to a stop. So that's rational. This one is irrational because 6 is not a perfect square. And this last one is rational because it involves a repeating decimal. Let's put in those answers real quick. Okay, in this problem, I'll give a little bit more detailed explanation. So we said that rational numbers, I'm going to write this out. Rational numbers are those with repeating or terminating decimals, ratios of integers or ordinary fractions, square roots of perfect squares. And the irrational numbers are going to include square roots of numbers that are not perfect squares and any multiple of pi, or any number multiplied by pi. Okay, so this first number, this has a repeating decimal. So this is a rational number because it involves a repeating decimal. In fact, for any of these problems, if you see any decimal at all, it's going to be a rational number because that decimal is either going to repeat or terminate, and in either case, it's rational. So any decimals mean that you should check the rational box here. This next number is rational because 36 is a perfect square. Remember what the perfect squares are? They are like a number multiplied by itself. So the first few perfect squares, I'll make a little table of them. Call the first column x and the second column x squared. 1 is a perfect square because it's 1 times 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And 6 times 6 is 36. So these numbers in the right-hand column are perfect squares. And if you see one of them under a square root sign, then that number is rational. So here we have the 36 under the square root sign. So this is going to be a rational number. This next number is irrational because it's a multiple of pi. It's 8 times pi. And that means that it is not rational. So it is irrational. This next number is a ratio of integers. It's a regular everyday fraction, so this is a rational number. This one down here is going to be irrational because in here we have the square root of a number. And is that number a perfect square? It's not. It's not on the right-hand side of my table here, and there's no whole number that you would multiply by itself to get 2. So this last one is irrational. All right, I'm going to put in those answers real quick, and then we'll do one more problem, again with a little bit of explanation. Okay, In this problem, the first one says the square root of 81. So we've got to ask ourselves, is 81 a perfect square? The answer is yes. 81 is 9 times 9. So the square root of 81 is going to be equal to the square root of 9 times 9, which is 9. This is actually equal to 9. And so 9 is a rational number. And because this expression, the square root of 81, involves the square root of a perfect square, it's a rational number. This next one down here, well, we see a decimal in it. So we've remembered that decimals always mean that the number is going to be rational. So we can check this box here. But the reason that this is a rational number is that any number with repeating decimals can be expressed as a fraction. In this next problem, we see the square root of 7. Is 7 a perfect square? No, there are no two whole numbers that you could multiply together to get 7. So this is irrational because 7 is not a perfect square. In this next number here, we see a decimal. So this is going to be a rational number. And in the last one, we have a multiple of pi, and any multiple of pi is irrational. So I'll put in those answers real quick. Okay, I hope that explanation was helpful for you. Please let me know in the comments if you have any questions at all. Thank you very much for watching.